Welcome to qnawire.
All right, so this is a problem involving the relationship between weight and mass on different astronomical objects. For part A, the gravitational acceleration on Io is actually irrelevant because we're just dealing with Earth. Um, so the weight of this watermelon, W standing for weight and not watermelon, and I'll put a little subscript E to help us remember that this is for Earth. um, is 44 newtons. But you know, um, equation-wise, that's going to be equal to the watermelon's mass, which is an intrinsic property. It doesn't change regardless of location or where the watermelon is, multiplied by the gravitational acceleration, which is a quantity that can vary from one astronomical body to another. So we'll give that a subscript E. So we know what GE is, and we know what WE is. That's given to us. So naturally, we're going to divide both sides by GE in order to solve for the mass. So you can find the mass by dividing the weight of the watermelon by the gravitational acceleration here on Earth. So those two numbers are supplied to us, or we could look it up in a table. Those are 44.0 and then 9.81 meters per second squared. Plug that into a calculator and then ends up with 4.49 kilograms. Okay, so part B actually starts off with a little trick question. And we'll have to invoke something that I said earlier, which is that the mass of an object does not change, regardless of its location of the universe. It's an intrinsic property. So we can actually already go ahead and assert what the mass of this watermelon must be on Io, and that's exactly the same as what we saw for in part A. That's 4.49 kilograms. So that was easy. However, the weight of an object can change from one body to another, so that's why I'm putting the subscripts on here. So the weight of this watermelon with subscript I is going to be equal to its mass multiplied by the gravitational acceleration near the surface of Io, so that's going to be GI. So we can actually already go ahead and plug in values since we can recycle our answers from the previous part. That's 4.49, as well as the G for Io, which is given to us, which is 1.81 meters per square second. So at the end of the day, we can plug that into a calculator and then get 8.12 to three significant figures, newtons, for that weight on Io. And then we are actually done.